Hello, technical pilots. Welcome back to this lecture. In this, we'll be covering aircraft brakes. I hope you are watching all of the videos in the playlist and you are making your own notes and you are revising them because that is how you are supposed to study in order to clear your DGCA exams. All right, so let's start with aircraft brakes. What aircraft brakes are? Brakes are what? They are used to decelerate an aircraft, right? Deceleration is done by use of brakes, obviously. And when do we have to decelerate an aircraft? Obviously during landings and also during rejected takeoff. In case you decide to reject a takeoff, then also you need your brakes in order to decelerate the aircraft, right? And then you have the second point, that is to they are used or they work by converting the kinetic energy into heat energy. So brakes, what they do, they convert kinetic energy into heat energy. What is kinetic energy? It is any energy when something is in motion, right? Energy which is possessed by an object in motion is what your kinetic energy, and your brakes convert this kinetic energy into your heat energy. So they dissipate in form of heat, right? So kinetic energy is being converted into heat energy. This you need to keep in your head, that your energy is being converted into what? Heat energy. All right. And the third point is that they work by creating friction between a fixed surface and a moving surface. So this that you're seeing here is a simple diagram of an aircraft brake. So this is your wheel, right? And it is connected with the axle to what? To another moving plate. So this plate is moving with the wheel. This metal plate that you're seeing here, no, this plate is moving with your wheel, right? And these orangish material that you're seeing on this part, this is your friction pads. So these pads are there to create friction. So what will happen when you apply the brakes, when you push it with your feet, the hydraulic fluid will move and it will push this friction plate against this wheel. So the friction plate will come in contact with your rotating metal disc like this. Now there is friction being created between the this plate, this moving plate, and your friction pads, right? So this friction will cause a lot of heat. So this will stop the aircraft, right? So the kinetic energy from this wheel is being transmitted and is getting converted into your heat energy, and that is how you stop the aircraft, right? So this is how the brakes work, by creating friction between a fixed surface and a moving surface. The fixed surface here is your friction pads, and the moving surface is your rotating metal disc, right? Now, in today's modern aircraft, there is a very big problem of heat dissipation. Why? See, as I mentioned already, that kinetic energy is getting converted in your heat energy, right? So this is the basic principle of brakes, right? That kinetic energy is getting converted into heat energy. But today's modern aircrafts are very heavy and very large. So this causes a lot of kinetic energy. Why? See, larger aircrafts means larger flying speeds, larger air speeds, larger landing speed, right? So when the aircraft is coming in for landing, it will be coming at a higher landing speed. Hence, the kinetic energy will be more, right? So the kinetic energy will be more, which means the heat generated will be also more, right? So heat and kinetic energy will go hand in hand, right? So if the kinetic energy is more, the aircraft is landing at a higher landing speed, so the heat energy will be more, and hence the major problem that we come across in larger aircraft is heat dissipation. So heat that is being created in the brakes is very deadly, right? It can cause fire, it can damage different multiple parts, right? Hence the solution for that was to avoid or to reduce the effect or the requirement of your brakes, right? And hence we'll develop some other method of decelerating the aircraft. These are the other methods. What are these? First is your reverse thrust. A reverse thrust is what? You are directing the flow of the engine. So the engine is what? Producing thrust like this, right? And reverse thrust is what? From your engines, you start to produce thrust outwards like this. So we'll study about that in details in later chapters. But this is how reverse thrust work. And then you have reverse pitch. You're changing the pitch of the propeller in a way that it creates thrust in the opposite, similar like a reverse thrust. And then you have spoilers. So spoilers does is what? They spoil the lift on the on the wing. We'll study about these in some other chapters, but these are the solution that we have for reducing the requirement of brakes, right? And They help by reducing the stress on the brakes so that we don't have a problem of heat dissipation. So still we do have this problem in modern aircrafts, and we'll see how we deal with them. All right, so next we have is disc brakes. What are disc brakes? Disc brakes are exactly the same that we saw earlier. So why are they known as disc brakes? The reason of disc is obviously that we have a disc. This thing that you're seeing here, this is your disc, and it is rotating with the wheel, right? So that is why it is called a disc brake, because we have a rotating disc, right? And all the modern aircrafts uses this system, right? So all of the modern aircrafts that you will be seeing are using this exact same principle, but it won't be this simple. There will be some additional components along with this, and then it will be used in modern aircrafts. This thing that you're seeing here, this is used in what your small trainer aircrafts, right? But exact same principle will be used in modern aircrafts, but with some additional components. So we'll be seeing what those additional components are. And so all the modern aircrafts uses this system for stopping the aircraft, slowing them down. In this system, the friction pads are pushed against the rotating metal disc, which rotates the wheel. Right, I explained this earlier. And in a smaller aircrafts, the pilots can apply the pressure by the foot, but in a larger aircraft, you need what? Hydraulics, right? So this is the first thing, right? In a larger aircraft, what additional component you need is hydraulics, right? So here you can see a foot is being placed, right? So which indicates that the pilot is being applying the pressure, right? But in a larger aircraft, the wheels will be larger, the systems, the components, everything will be larger and heavier, right? That's why you need what? Hydraulic systems to be pushing this thing, right? You cannot use your foot to push it, right? So the first difference would be what? You need what? Hydraulic pressure in order to push the controls or to apply the brakes. Right. So disc brakes in a larger aircraft. So first thing was what? Hydraulics, right? The pressure is applied by hydraulics. And whenever we are using hydraulics, what do we need? A backup system, right? In case of a hydraulic failure, there is an alternate hydraulic power source or an accumulator. Accumulator is what? Which stores your hydraulic fluid under what? Pressure. This we studied in hydraulics. If you haven't watched that video, go ahead and watch it. Right. So the third point is that there are multiple brake discs. So this we'll see in detail. And what are these multiple brake discs? So basically, in our previous slide, we saw that there was a moving metal plate, right? And there was your what? Friction pads, right? So these friction pads were being pushed together in the moving plate and hence stopping the aircraft. So in a larger aircraft, what do? We add multiple of such plates and braking system. One more plate, another braking system. Why do we do this? We do this for a sole purpose of heat dissipation. As I already mentioned, that heat dissipation is a very big problem, right? So we do is we add multiple of these friction pads and moving your plates, right? So we have pads, plate, pads, plate, pads, plate, like this, right? And since we have multiple brake plates, that's why we call the system what? Multi-disc brakes, right? So in modern aircraft, if someone asks you what system do we use, so just tell them we use multi-disc brakes, right? So multi-disc brakes are what used in actual modern aircrafts, like in a bigger aircrafts, right? Because smaller aircrafts can use what? SIF disc brakes, because you can just have your disc which is pressing against your friction pad and then it is stopping the aircraft. But in a larger aircraft, you need what? Multi-disc brake. Why do we need multi-disc? So you see here in this picture, you can see that there are multiple discs. What are these multiple discs? So these are what? Watch closely. These that you're seeing here, these which are marked, these are your brake plates. Brake plates are also your rotors, means that these are the rotating plate. These that you're seeing here, these are your rotating plates. So these plates will be continuously rotating with your wheel. So they are attached with the wheel, right? The wheel is rotating and these plates are also rotating. All of these plates are rotating. So these plates are like this and they are attached with the wheel. So they are rotating with the wheel. All right. So these are your rotors. All right. And then you have your stators. What are stators? Stator are your exact brake pads. The brake pads that you saw, the friction pads, right? So these are your brake pads. They're also known as brake pads and these are stationary. So they are attached on the mountings, right? So these pads are stationary and you have your rotors in between them, right? So you form a sandwich kind of layer where you have your friction pads or your pad assembly and your brake plates, right? So these kind of system is in a multi-disc braking system, right? So you have what rotors and stators. So these plates that you're seeing here, these these are your stator. These things are your stator plates, right? So all of these are stators, and they are what pad assembly. So they have what friction material on them, and these things, these are your brake plates or your rotors, right? So these are rotating with the wheel, and these things are stationary. Now, as it is also written here, that the rotor rotates with the wheel axle while the stator is contains the braking material. All right, this thing that is mentioned here, you understood that. Then we have the stator rotor assembly is fitted between pressure plate and thrust plate. So we have these two plates that are like marks the beginning and end of the complete system. So you have a pressure plate which is here. So this first plate is known as your pressure plate. So this is your pressure plate, and you have something known as a thrust plate. So the last plate over here, this will be your thrust plate, right? So you have a pressure plate over here, and you have a plate at the end, right? And you have what your pistons. So pistons are what? These are your pistons. These this thing that I'm marking here, these are your pistons, right? I'll tell you what exactly and how it works shortly. So these are your pistons, right? And they are fixed in a torque plate. Torque plate is nothing but this whole thing that you're seeing here, this stationary part. This is your whole torque plate, right? So pistons, and they are fitted in your torque plate, right? This you need to keep in your head. Then when braking, when brakes are applied, pistons are pushed by the pressure plate, hence squeezing the rotor stator assembly between the pressure plate and the thrust plate. So exactly what is happening, we'll see in the next slide. So how is all of this working? So see closely. This thing that you're seeing here is what your piston, right? So these are your pistons, right? Now what is happening that the hydraulic fluid when you apply brakes will be rushed in and it will push these pistons, right? So the hydraulic fluid will come and it will push these pistons, right? So the forces will be applied on these pistons, all right? So the pistons will move inwards, right? And the pistons will then apply force on what? It will apply force on the pressure plate. This is your pressure plate, right? So the pistons will apply the forces on the pressure plate. Now, since the pressure plate and the thrust plate, the thrust plate and the pressure plate are having all of these discs in between, right? So all of these discs of stators and rotors are between the pressure plate and thrust plate, right? And this thing is getting compressed, right? The whole thrust plate and the pressure plate is being compressed because the pistons are pushing. So the pressure plate is now being pushed. So and the thrust plate is here. So the whole assembly, this whole unit is getting compressed, right? And this whole unit is containing what? Your rotors and your stators. Stators are your brake pads, right? The friction material. Again, your rotors and then your stators and then rotors and then your stators. So all of this thing is being what? Compressed because of the forces from the piston, right? And since this is getting compressed, what is happening? These things are coming in contact with each other, right? The stators and the rotors, they are coming in contact. So as they're coming in contact, the friction is causing them to stop, right? And converting what kinetic energy into what heat energy, right? So this is exactly how your multi-disc brakes work. And then we have something known as torque rods. So they are nothing, they are just attached at the landing gear. They are there to resist the twisting motion during braking. Just keep that in head. So these things that you're seeing here, these are your torque plates. So these things that you're seeing here, these are what your torque plates. So the torque plates are doing what? They are resisting any twisting motion, because whenever you apply brakes, as I mentioned already, that the brakes are very, very powerful and very what a lot of heat is generated. It is enormous because of the size of the aircraft, right? So this much braking might also twist the landing gear, right? So that is why you attach something known as a torque plate to resist any twisting motion. All right. Then in today's modern aircraft, as I mentioned, that heat dissipation is a very big problem, right? So how do we solve it? So in nowadays, rotors are made of interconnecting individual parts. So this thing that you're seeing here, this picture, it shows that this is what your rotor. So this thing is what rotating, right? So this is your rotor which was rotating with the wheel. Okay. So this rotor is made with interconnecting parts. These, you can see that this is a single individual part. Then there is this part, there's this part. So all of these parts are separate and they are attached with what bolts and nuts. So this is how today's rotors are made. Why are they splitted into pieces? It's because of heat dissipation. So whenever you attach different parts together, then the heat dissipation is a lot better, right? So this is one thing that is done in today's braking system. And also the rotors are made of what? Carbon. So the rotors are made of carbon materials instead of steel, because steel has because sorry, the carbon has better dissipation property, heat dissipation property than steel. That is why we use carbon to make rotors, and we also make rotors in splitted form, like we connect different individual parts to make your rotor. All right. Then we have brake fade. What is brake fade? So whenever the aircraft brakes become too hot, their ability to absorb any further energy rapidly decreases. This is known as brake fade. So, obviously, the brakes get hotter whenever they try to stop the aircraft, whenever they try to decelerate the aircraft, right? Why? Obviously, again, the kinetic energy is getting converted in your heat energy. So, the heat is causing the brakes to get hot, right? So, if you use too much of the braking, right, if you try to stop the aircraft with a lot of force, a lot of braking, then the brakes can get too much hot, right? If the brakes get too hot, their ability to absorb any further heat rapidly decreases, so they are not able to absorb any further heat. If you stop the aircraft, so if you apply too much of the brakes together, then the brakes get too hot and they are not able to absorb any other energy, right? So this is known as brake fade. All right, what is a automatic brake adjuster? So earlier we saw that in our aircraft we had rotor blades and stator plates, right? So this is your rotor, and then you had another stator like this, then another rotor. So this is how the assembly was. And what was here? This was your pressure plate, right? This was your pressure plate, and this was your thrust plate, right? So the whole thing was sandwiched in between, right? And there were pistons attached here, right? So the pistons were pushing on the pressure plate, right? And that is how the brakes were applied. So tell me, what will happen if I apply the brakes? The piston will move forward, right? They'll compress this whole thing together, and the rotor plates and the stator plates will come in contact, right? And the brakes will be applied. But tell me one thing, what will happen if I release the brakes? If I release the brakes, do you think the plates will move apart by themselves? No, right? The plates will still be in contact, right? These plates will be still in contact, right? And the brakes will be still applied even if I have released the brakes, right? So there has to be something to move the plates apart when I release the brakes, right? So that is where the automatic brake adjuster comes in. So automatic brake adjuster is this thing that is spring loaded. So it has a spring and it is attached with what? Your pressure plate. So this was your pressure plate, and the system, this automatic brake adjuster thing, is attached to your pressure plate. So what will happen? The automatic brake adjuster, when I release the brakes, will pull the pressure plate backwards. So this pressure plate, this thing, will be pulled backwards like this whenever I release the brakes. So this will move the all the stators backwards. Sorry, all the rotors backward, because the stators don't move, right? So the rotors will be moved backwards, right? So it will move all the stator plates. So the pressure plate will be moved backwards and it will decompress the whole thing, whole the assembly, right? So it will move apart your stator and rotor blades. So hence it will release the brakes. So this is the first purpose, that is, they can pull the pressure plate backwards when the brake is released, right? So whenever you release the brakes, the spring mechanism kicks in and it pulls back the pressure plate, and hence you release the brakes, right? The second thing it does is they also maintain a constant running clearance, hence compensating for any brake wear automatically. I'll tell you what this is. What is a constant running clearance, first of all? So in this diagram, this thing that you're seeing here, these bars, these are your rotor, all right? And these black bars that you're seeing, these are your stators, all right? So a running clearance is nothing but the gap between your rotor and stator blades, all right? So this gap that you're seeing here, this little gap is what your running clearance. Again, here also the gap is similar. It is also your running clearance. This gap is also there. This is your running clearance. So you can see that the gap is constant. This is constant, right? And even this gap is same when this gap has the same size. So this is called as a constant running clearance, right? So the running clearance is there and it is constant, all right? But with time, what will happen? See, after hundreds of use or a thousand of use, what will happen? The black colored brake pad that you're seeing here, this thing, it will be having damages. It will wear apart, right? So this thing will damage and it will reduce in size, right? Because with time it will be rubbed against the stators and sorry, it will be rubbed against the rotor. So then this thing will develop wear and it will reduce in size. So as it will reduce in size, what will happen to the running clearance? The running clearance will increase, right? Since these black parts will be rubbed and will become lesser size, right? Will become of smaller size. So the running clearance will increase, right? This gap will increase, and hence the running clearance won't be constant, right? But this thing is avoided by the use of what your this assembly, which is your automatic brake adjuster, right? So your automatic brake adjuster compensate for this loss of material, for this loss of brake pads, for this loss of stator, right? With time this will be rubbed, but because of the automatic brake adjuster, the gap between stator and rotor or the running clearance will be kept constant, right? So even if there is damage to the black part or your stators, then also the running clearance will be kept constant because of the automatic brake adjuster, right? So in the second point, it is written they also maintain a constant running clearance, hence compensating for any brake wear automatically, right? Even if the brake wears, then also the running clearance will be constant. And the first point was what? They can pull back the pressure plate whenever the brakes are released. All right. So this is your automatic brake adjuster. Then we have something known as brake drag. What is brake drag? So uh, if the spring mechanism failed, what is the spring mechanism? This thing that we saw earlier. This was what? Spring mechanism. It was pulling the pressure plate backwards whenever we release the brakes. All right. So if the spring mechanism it damages, then what will happen? That the spring will not be able to pull the pressure plate backwards, right? The spring won't be able to pull the pressure plate backwards. So the stator and the rotor assembly will still be in contact, right? The stator and rotor will still be in contact even when I have released the brakes, right? Because the spring has failed, hence it is not able to pull the pressure plate backward, and hence there is still the pressure, the stator and rotor assembly are still in contact, right? So what will this cause? It will cause serious brake wear, right? Obviously, if I have released the brake, then also the brakes are actually applied, right? Because the spring has failed, right? So it will create a lot of brake wear, which is known as brake drag. All right. So you understood what brake drag is, right? And if there is a lot of brake drag, then it can cause the brakes to heat up very quickly. Obviously, the plates are in contact, so it will cause them to heat up, and this can result in what? Brake fade, right? So earlier we saw was brake fade, which was what? When the brakes get too much hot, then they are not able to absorb any further energy, which is known as brake fade. So brake drag can cause brake fade. Understood? All right. And there is also something known as brake fire. Obviously, there can be fire if there is too much heat. All right. So understood what brake drag is? All right. Then we have is measuring brake wear. All right. So this brake material that you're seeing here, this thing that was your stator. So this stator keeps on getting damaged with time, right? With all of your flights, this will get damaged, right? There will be damage because the stator and the rotors are coming in contact, which is creating friction, which is creating heat. So the brakes are, so it is natural for the brakes to have some damage, to have wear, right? So this is normal, right? But there has to be an indication which tells us whether enough brake material or the brake pad, this thing, the black part, is remaining or no. If this is worn beyond the limits, then we'll have to replace it, right? So, what is this indicator? How do we know how much black material is left? So, we use what? A retraction pin or a wear indicator pin. So, this thing that you're seeing here, this rod, this is your wear indicator pin. In your aircraft, you can see that this part that you're seeing here, this little pin that is being popping out, is your what? Wear indicator pin or retraction pin. So this pin is it is good if it is visible, right? If you are able to see the pin, which means the brake material is still remaining. In the first case, it is all right. You can see the pin, right? But in the second case, the pin is gone, right? The pin is not visible. And how is it measuring? You can see it very simple. The brake material is here. The springs are attached to the pin, and the pin is moving inwards as the brake material get damaged. So in the second image, the brake material has faded. The brakes has got worn out, so the pen has moved inwards and hence it is not visible, right? So the brakes are to be replaced now, right? So that is how the length of the pen visible after applying the brakes gives an indication of the brake wear. This thing that is written here, that after applying brakes, is very important for your exams, right? So the length of pen visible after applying brakes. So whenever you apply the brakes, then only you check how much wear is there in the brake, right? So you need to first apply the brakes and then check how much pin is outward, right? You cannot check it when the brakes are released, right? Next is skid. What do you understand from skid? You might have seen bikes and cars being skidding on the runway, or sorry, on the roads, right? So, what is skid actually? So, skid is something dangerous, you know this, right? And whenever something skids, you lose what? Your directional control. First thing you lose is your directional control. Second thing that you lose is your braking action, right? So, these are two things that you lose. Firstly, you lose directional control. That is, you're not able to control where the vehicle or the aircraft in this case is going, right? You're not able to turn the aircraft left or right. The second thing that will happen is you will lose your braking efficiency by a lot. Okay, so if something is skidding, it means your braking efficiency has reduced by a lot. So you won't stop in a smaller amount of runway, right? If you are skidding. Okay, so during braking, the the wheel of the aircraft gets locked. Okay, and the braking action is very poor, as I said, and the aircraft also loses control. Okay, so the first thing, and the directional control is lost. You lose the control of the aircraft. You're not able to control whether it go left or right. And the second thing is your braking action is poor. You're not able to stop in the small amount of runway, right? Alright, so I'll show you a video in which you will see how a car is skidding on the road, and then you'll see how it loses directional control, how the car is not able to turn, right? And then you'll see how do we prevent this skidding. How do we use ABS in our cars and bike? We use what? ABS to prevent skid, right? And our aircraft, we use a anti-skid system. Okay, so you'll see that in this video, and it will help you a lot in understanding how and what is a skid and how do we prevent it.
When the driver fully applies the brakes in a vehicle without the anti-lock brake system, the brakes can lock. This causes the wheels to stop turning, which makes the tires skid. Skidding tires have very little grip and are not effective at stopping or turning the vehicle, so the driver may be unable to take evasive action. With ABS, when the driver fully applies the brakes, the system uses sensors to detect any brake lockup and rapidly pulses that brake to prevent it from locking. This helps to prevent skidding so the tires can maintain grip. It also helps to allow the vehicle to be steered around obstacles while braking.
All right, so that you saw was what? ABS. But we don't use ABS in our aircraft, so don't confuse it with our aircraft system. We use what? Anti-skid system. All right, but the working is exactly the same. Like if the wheel of our aircraft locks, so whenever the wheel of the aircraft or the car in this case was locked, then the skid will happen for sure. So it was what? Rolling on the runway or on the road, then the wheel was locked, you saw, and then what was happening? The car was skidding, and when the driver tried to turn, when there were pebbles, no, they were falling from the mountains, and when the driver tried to turn the car, there were pebbles in the way, but the car was not turning, right? If you didn't saw it, then just rewind the video and watch it again. That the car was not able to turn, right? Neither was the car able to stop, right? But in the second case with the ABS, what was happening? The car was able to turn and also stop, right? Or slow down, right? So this is how the skid is being prevented in this car, right? And that's almost as similar as in our aircraft. So the anti-skid system in our aircraft uses these three components. The first one is your wheel speed indicator, or sorry, the wheel speed sensor. It senses your wheel's speed. The second thing is the anti-skid unit. It computes that value. And then we have an anti-skid valve. So this works as a servo where it controls the fluid, right? I'll show you how this all works. We'll move forward now. The anti-skid system has a considerable impact on the landing distance required, right? As I told you already, that the skidding wheel, a wheel which is locked, a wheel which is skidding on the runway, has a very, very poor first thing, braking efficiency. It brakes very slowly. The second thing was what? Directional control, right? So, since the braking efficiency is very, very poor, which means the aircraft will consume a lot more runway, right? So, here you can see that this is with anti skid system being inoperative, and the green line is anti-skid system serviceable, right? So when the system is inoperative, you see that this is the amount of extra runway it is consuming, right? So since the wheels are skidding, they're consuming a lot more runway when as compared to when the wheels are not skidding. Okay, and anti-skid system not just the skid prevention; it serves two more purposes, right? So anti-skid system serves three purposes. The first one is what? Touchdown protection. Second is your skid prevention that we saw. The third is your wheel lock prevention. All right, we'll go one by one. The first one, touchdown protection. What is a touchdown protection? So the anti-skid system, it prevents the brakes to be applied before the touchdown. So if the aircraft is approaching, aircraft is coming in to land, right? And the pilot applies brake right here. At this particular point, if pilots apply brake, then the brakes would not be selected, right? So the aircraft, when it touches down and the wheels start to rotate by themselves, obviously because the aircraft will roll, no? So the wheel will start to turn by themselves first, and then only the pilot will be able to select brakes, right? Why? Because obviously, if the brakes are selected here only, the wheels are locked, right? And when the wheels will touch the runway, the wheels are still locked, so the aircraft can start to skid, right? So the wheels are let to rotate by themselves for a while before the pilot selects the brake. All right. So this is a protection given by your anti-skid system, right? So your anti-skid systems, they do not let the pilot to select the brakes at this position, and then when the wheel starts to rotate by itself on the runway, then only the pilots can start to select the brakes. All right, so it uses what? Air ground logic system. It is nothing, it's just a logic system in the aircraft which tells the aircraft computers that the aircraft is in air or on ground, right? So it uses this logic system. Then we have, as the aircraft touches down and the wheel starts to spin, then only the brakes can be applied, right? So as I already told you, that when the aircraft touches down, when the wheel starts to rotate, then only pilots can start to apply the brakes. So this is a protection system so that the aircraft would not skid on the runway, right? And lose direction control, lose the braking efficiency. That's why this is a protection given by the anti-skid system. So it comes under, bro, that sounds bad, but yeah, your anti-skid system, uh, yeah. So your anti-skid system works by this. All right, ignore this mess. So next purpose of an anti-skid system is what? Skid prevention. Obvious, right? So it prevents skid. How does it prevent a skid? So the sensors that we saw, the three components, right? The sensor, they monitor the rate of deceleration, right? It is not acceleration, it is deceleration of the each wheel, right? So we have multiple wheels in the craft, and there is a anti-skid sensor. So what it does, you have these wheels, right? So there will be a sensor. What it does is it measures the rate of deceleration of each wheel. So each wheel will be having a sensor, and it will measure the rate of deceleration of each wheel. Okay, so this sensor will then compute and find out which wheel is having highest rate of deceleration. For example, this particular wheel here is getting a highest rate of deceleration, which means this is getting slower and slower very fast. So this wheel is getting a highest rate of deceleration. So this might cause skid, right? So what the aircraft system will do now is whatever braking pressure it was applying to this wheel, it will release that. So the braking pressure that was applying to all the wheels, right? So the aircraft system will release the braking pressure for this particular wheel. So whatever the braking pressure was applied here, it will remove this pressure. It will free this wheel until it starts to increase the rate of SL until the rate of deceleration comes back to normal. Normal is what? As other wheels, right? This wheel, this wheel, this wheel, this wheel, all the wheels should have a same rate of deceleration. Then only the aircraft will not skid, right? So it will release all of the braking pressure from this wheel, and then the wheel will again start to rotate faster. Then it will come back to its normal rate of deceleration, and then the braking pressure will be applied again, right? So the sensors, they monitor the rate of deceleration of each wheel. If any wheel has a high rate of deceleration, then the hydraulic fluid is not supplied to that wheel, right? And then the wheel until the wheel starts to spin up again, right? As I already explained, this is written here. Now, the third prevention is what? Wheel lock prevention. So, if any wheel is locked during landing roll due to, for example, ice, or it could be anything else which is locking the wheel, right? If your aircraft wheel, any of the wheel is locked for any reason, for example, there is some ice which locked this wheel during landing roll. So, what it will do, the anti-skid system will release the braking pressure completely from that wheel until it starts to roll again, then reapply pressure, right? So there was ice that was stopping this wheel from rotating. On top of that, there was our braking pressure, right? Since we were trying to stop the aircraft, obviously, we had our braking pressure. So the wheel was already not rotating because of ice, and now we have already also applied brake pressure. So the wheel is not rotating, and the wheel is locked, so it will skid, right? So what do we do? The aircraft system detects this, and the aircraft system removes the braking pressure and the wheel until the wheel starts to rotate again, right? And then the aircraft can continue to roll. All right. So whole point of this system is to never let any wheel lock, right? So anything that was stopping the wheel, the braking pressure was being removed, right? If any wheel is getting locked, then the aircraft will skid, right? So the whole point of the system is to prevent locking of any wheel. All right. Then there are some points to remember. One is a torque sensor. So a torque sensor is usually fitted in each wheel, which detects excess torque, then sends a signal to the servo, reduce the hydraulic pressure on that wheel, which prevents the damage to the landing gear stud. So again, something similar to what we saw was torque strud. So there was a landing gear. You had something known as a torque strud, right? Which was preventing any excess twisting forces, right? So a torque sensor is actually a sensor which is fitted on each wheel. So each will be having their own torque sensor. These torque sensors do is they measure the amount of torque being felt on the landing gear, right? So this torque will be calculated, and if the torque is too much, if it exceeds a certain limit, which could damage the landing gear strut, right? This strut can get damaged. So what will it do? It will again release the hydraulic pressure from that wheel. So what it will do, it will release that pressure, and the torque will also reduce, obviously, because the braking pressure is removed, right? So the torque will reduce, and hence the aircrafts will be in a safe. So the aircraft stud won't get damaged, right? The aircraft stud will be safe, right? Then we have anti-skid system is turned off below 10 knots. This is not fixed, but usually below 10 knots, what happens is you turn off your or the aircraft automatically turns off its anti-skid system, so the pilot can have full control while taxiing, right? At slow speed, at below 10 knots, the aircraft is obviously at not a risk of skidding, right? So the anti-skid system goes to sleep mode, turns off itself, so the pilots can easily maneuver the aircraft by themselves at such a low speed. While taxiing, the pilots want a full control. That's why the anti-skid system is turned off. Then there is auto braking system. So auto braking, as the name suggests, it automatically applies brake the correct amount of braking pressure, right? So the system in the aircraft which automatically applies the correct amount of braking pressure is a auto brake system, right? And it has various modes depending on the braking intensity, right? What are these different modes? In Airbus, you will find low, medium, and max, right? So you just press these buttons. You just have these buttons in the cockpit and you press that you want low braking, medium braking, or max braking. And the aircraft automatically applies the brake accordingly, right? And then you have in Boeing, you have a rejected takeoff RTO button, one, two, and three, right? So in Airbus, you have low, medium, and high. Just like that, you have in Boeing RTO 1, 2, and 3. RTO here is nothing but a rejected takeoff. So in case when you are on the runway, you are ready for takeoff. That time you'll select your brakes in a Boeing aircraft as RTO, right? So if while during takeoff roll you decide to reject the takeoff, the aircraft will automatically set the maximum brakes, that is RTO, rejected takeoff. So it will set the maximum brakes, try to stop the aircraft in the shortest possible run, right? RTO is similar to Boeing in Airbus Max, right? So these are the maximum settings, all right? In Boeing, you can see this that you have what off, one, two, and three, and a RTO switch here, right? And it is a knob in Boeing. But in Airbus, you have buttons for low, medium, and high. Oh, sorry, low, medium, and max, right? So you have buttons here, and in Boeing, you have what? A knob which has RTO 1, 2, and 3. Then auto brake system again, auto brake will disarm, right? So auto brakes, they can be disarmed, right? They can be switched to off position by the computer itself or by the pilots. So if the computer itself detects the auto brake system, then the disarm light will illuminate, right? So there is a auto brake disarm light that you can see here. This light, it illuminates if the auto brake system is disarmed by the system, by the computer itself, right? So why will the computer disarm? Why will the computer disarm the auto brake system? So the first thing is it can disarm if the anti-skid system becomes inoperative, right? So for auto brakes to function, the anti-skid system needs to be working, right? So if the anti-skid system fails, then the auto brake will also become inoperative automatically, right? So when this happens, the lights will illuminate. And if the speed brakes are retracted during landing, right? If you are coming in for landing, you have landed the aircraft was applying auto brakes, and then you suddenly go to the spoilers lever and you reduce your spoilers. What will happen? The aircraft auto brake will then disarm. Why? Because the computer is thinking that you might not want to stop the aircraft. You might be preparing for a go around or a missed approach, right? So the computers will disarm the auto brake system. It will again indicate it here on their a light will be displayed auto brake disarm, right? And the third is if the thrust levers are advanced. So if you move the thrust lever forward while you are landing roll, which again means that you are trying to maybe do a rejected landing or a missed approach go around, right? So in that case also the auto brakes will disarm and then a light will be illuminated. But if the pilots themselves apply pressure on the brakes, these brakes are what? The pedal, the brakes that are on your feet. If the pilot applies that brake, the auto braking system will automatically disengage, but there will be no light illuminated because the pilot intentionally did that, right? So the computer did not do it, the lights will not be illuminated. Or the pilots did it, the lights will be illuminated, right? So the pilots applied the brake by their feet, then it means that the pilots want to control the aircraft manually, right? So the brakes, so the anti-auto braking system will then go to disarm mode, right? but the lights will not be illuminated. And if the pilot manually pushes the button or rotate the knob to off position, obviously if the pilot moves it to the off position, then also the light will not be illuminated because the pilot himself or herself did it, right? So it was an intentional action, right? So there won't be any lights if the pilot did it by themselves. All right, that is it for this lecture. The breakings is covered completely here, and I hope you have watched the lecture till the end. If you're watching this part, then you're definitely gonna ace your exam, and I hope you are making your notes and revising them. And we are almost done with aircraft systems. Although there is around 40% remaining, we are almost covered like 60%, and I'll be covering that soon for sure. And thank you for watching till then. Bye bye. Enjoy.